thank you for having me. I was very glad to get Bill Zimeia come here. I come all the way from Brazil. My name is Bernardo Furtado, and I work at IPEA. I think the best suggestion of what IPEA is, we are 200 PhD researchers that we work at near the ministry in Brasilia. So we are a think tank attached to the government. So we are in a dilemma between everyday government bureaucracy and doing research and science, and then we try to help the government monitor and evaluate policy. My personal background, I'm an architect. I did a master in geography, and then went on to a PhD in urban economics, and then I did a cellular automata model to simulate real estate prices over 100 years in the city of Belo Horizonte. Then the talk is very short. I really planned for the 10 minutes that Bill had talked to us about. And basically, I'm going to talk about this model I've been working on since 2015. It's called Policy Space. And then, of course, the title of the slides, Machine Learning Simulates an Agent-Based Model. In fact, it's a machine learning tentative to simulate policy space, the model specifically. Some of the background, I was very lucky in 2015 to put together a group of leading scientists, including Bill Rand and some colleagues from Santa Fe, and Luis Bittencourt and Miguel Fuentes, and some other people across the road from Germany, Japan, and we put together this modeling complex systems for public policy. It's a collection of chapters, but each one of the authors tried to see how we can get this approach, this understanding of what complex systems and complexity science is and apply it to policy. And then, like I said, I'm talking about this policy space. There is a book about discussing a little bit the goals, motivations, and the rules and the discussion. Like I said, I'm not a computer science, so it's just an effort of a policy spatial analyst to try to do some calculation and provide quantitative analysis to the policymakers. So what is policy space? Basically, it's an open source, spatial economic, and then spatial is very relevant here, intra-urban agent-based model. It has three markets. It follows the Langnick and Gaffel approach. So it's called by Herbert David a simple model because there is no credit market. And on those three markets, we apply a 5 different tax system, and we try to empirically simulate 46 metropolitan regions in Brazil. Basically, in Brazil, metropolitan regions are very fragmented, and we have a lot of municipalities. I think Brazil is a single case that the municipality is an entity of government, independent, like you have the union, we have the state, and then we have the municipalities. And then, as you know, it is very difficult to provide network service, transport, and sanitation, for example, across different mayors, different budget organizers. So we simulated from 20 to 2020. The goal was to investigate alternative tax distribution among municipalities. As you know, in the social sciences, we cannot just go and do experiments. Oh, let's stop vaccination for 10 years and see what happens. That doesn't work. So this is a system that I tried 4 different alternatives of putting together the budgets of the municipalities in specific metropolitan regions. And then we test, and we wanted to show the policymakers that a less fragmented metropolitan region is socially better. We know that, but it's in the urban literature is a lot of qualitative arguments. I wanted to introduce some quantitative details. So in the end, the question is, what should the government do? I like very much the idea of nudge, right? We at IPEA, we try to show policymakers how we can nudge them, like in the era example of Ivan, how can we nudge the government in the right direction? For example, should we put together some municipalities and work against more fragmentation in the case of policy space? So just a few details about the model. I'm not going to get too long on that. It's available on GitHub. Like I said, I learned Python some 5 years ago, so I'm sure there's a lot of things you can can teach me. It's developed from scratch in Python. All the available Mason and Repast were in Java, and I thought they were more difficult. Python is a beautiful language. Basically, we have families, and within the families we have workers. The decision on the budget is always made together by the families, but the workers individually work and earn their salaries. We also have firms, and then, of course, we have the municipalities. It's all official data, so I have the shape files of the actual municipalities, and I can differentiate between urban and non-urban areas. And then within the urban areas, I have almost like a census tract information, so I put the correct people at the correct census tract with the correct years of education and age and schooling. And then the task of the municipalities is just to collect those 5 taxes and invest the taxes linearly, transforming a quality of life index upwards. So the goods market is very simple. It's a homogeneous goods market. There is no sectors. The labor market, and then we have a real estate market. But the thing is, all markets, they do have spatial rules. And then, for example, firms compete by price, of course, the best price, but they also compete for buyers that are nearby. And when you are hiring the labor market, you look for more qualified worker because he is more productive, but you're also checking those that live nearby. And then it's a mixture of parameters and rules, because we have a parameter, for example, which is the percentage of the population who is going to be chosen by proximity. And then if I turn it to 0, that rule doesn't exist. And this one in particular I found to be very interesting. Any value from 0 to 1, the model works fine. If it gets to 0 or to 1, the model collapses. And then, of course, it's very dynamic, because if there is a real estate market, families can buy other houses, and then they move to the next house, and then all the labor market changes because of proximity and everything. And then, of course, the jobs are also mobile, so you have all this family thing in which you work close by now, and then you move to another house, and your job becomes distant, and all this spatial interplay is in the model. So validation is really important. I really enjoyed Sanders' presentation earlier. But the validation here is more in a qualitative sense. I dedicated some time for that in the book, and I tried to develop a cumulative process in which I choose 3 or 4 information, and I go validating the model in steps. And in the end, I get what I validate, the strongest validation, is because I am able to replicate the amount and the distribution of tax system of the model. So I have the markets, I collect the taxes, and then I compare with the empirical data of the taxes, and then the consumption tax was about the same relative value that you can observe for the municipalities in Brazil, getting data from the literature and data from the Treasury Secretary. So in my opinion, it's a weak validation, but the model is validated. So that was back in 2018. Now I'm on phase 2, and I have answered the first question. I have published a paper that clearly the message of phase 1 is if we put all the municipality and metropolitan region together, the quality of life will increase, although marginally, because the distribution of taxes is just a small percentage of the taxes. But what I found more relevant is that we have a transference fund in Brazil that favors poorer and larger municipalities. And this fund is very relevant. And if we take away, if a legislator in a meeting in Brasilia has an idea and decides to stop this transference fund, that would be very bad for the municipalities and economic well-being as a whole. So phase 2 now, we are asking questions about real estate. In Brazil, as you know, we're very poor. More than 55% of families cannot buy a house. And then we have had this huge program called My House, My Life, Minha Casa, Minha Vida, from Dilma presidency. And we constructed 10 million houses, which is pretty much, but it is still a lot less than we needed. And then the the conclusion of this is the government has to provide subsidies to buy houses. And the next test we're going to apply to policy space is this. Should we, for example, give money for rental? Or should we give money for buying a house? And we want to test that and come to a conclusion about if we have the same amount of money, how should we invest this as a government? So this is, of course, what I think are the contributions of policy space. First, it's empirical, official data. It's a framework, of course. It's like I made a huge model to answer one simple question, and then I have all this framework that I can ask other questions about that. It's intra-urban, spatial rules across all markets. Spatial is very important. And then it's important, especially if you are now analyzing housing, yes? Rob was talking earlier about that very good housing agent-based model about all these very great authors. But there isn't much follow-up, right? We know that real estate is very complex. I had this idea for so long, and then I was checking some very recent literature on macroeconomics, and then there is Edward Glaser from the University of Chicago, who's a very good professor in urban economics, and they say it very clearly. We don't know all the factors that affect real estate because it's so complex. We have all this spatial and neighborhood influence, for example, if you're in a school district or not, if it's an open space, if there's a park, if you're in Brazil, if the favela is nearby or not. And then you have all this macroeconomic, what's the credit rate, and is the Fed going to increase interest or not, and do we have a house bubble? And then you have the fiscal problem, and then we have the construction, which is a lagging market. You start making a decision to construct, and then the real estate comes to the market only 5 years later when the interest rate is completely different and all the thing. And then you have the family constraints, and then your wife gets a job somewhere else, you have to move and everything. So it's economics in time and space, and we don't have a hold on that. That's why I really want to do a good model on real estate. And then finally, policy space is a very naive, I know, attempt to join a little bit of macroeconomics from very good models from Herbert David and company people in Italy. And then we have a lot of land use models, but then it's just the urban tissue. It's devoid of some of the relevant economics. And then we have a lot of good transport models. And then policy space now also has a transit layer, because of course I know where people live, I know where people work, I know how they are changing, and then I have all the demand side of my transport layer. So all this to come to machine learning simulates policy space. I think it's the best thing about the paper is the title. Yes, if you get the title, it's fine. The rest is not that good. It was just exploratory exercise, really. I was doing a course on machine learning, and the paper was the end of the course work. It attempts to train, because after I have done policy space and I had to run so many different configurations of parameters, it does have an inbuilt parameter space search. So you can choose a parameter and then you run from 0 to 1, like 20 times if you want. It's all built in. But of course, everything is set as variables, right? You choose one alpha, and then you run the parameter, and then you choose beta, and you run it. And I wanted to run all with all, but that's very computational heavily. So I thought, well, I have all these configuration parameters, and then I have all these outputs, right? The model outputs a lot of macroeconomic indicators, such as GDP and inflation and family consumption, unemployment, Gini inequality, Gini coefficient. And so I had, could I map the configuration parameters straight to the output? And of course, I didn't get the explanation, but because I built the model I know about how the rules work. And then could I make this mapping? And then I would be able to vary a little more the parameters. And then I was interested in not only replicating the model, but could we have a socially optimal target? For example, in this case, I chose which are the best GDP and least inequality targets, right? So out of the 13 parameters, I chose the targets to be those with higher GDP and less inequality. And then I trained the model, and later I did 100,000 variations of my parameters to check which parameters would score on the high socially optimal results. Yes? And then what insight I could get from that is that which of those 67 parameters, but in fact 46 of them are the metropolitan region. So it's a fairly not many degrees of freedom model, right? You have some few parameters, only 20 something, and I know each one. For example, one is productivity of the employee, and then so if this parameter is not good in this larger simulation, it means that the government should work on productivity policies. And then there is another one that is, for example, labor market. How rigid is it? In practice, what it means is, does the firm go to the market all the time looking for new workers? So it's a more optimal, dynamic labor market. Or does the firm go to the market only once in a while and keeps with the same worker a longer time? So there were these twofold objectives. In one sense, I could check the robustness of my calibration, and most of the parameters were the same. And at the same time, I could learn which parameters would have to change to get optimal results, and that was the idea of the exercise. So some insights in future from this simple, naive simulation. When you do the real estate market more dynamic, of course, we can measure that. The economy is better for everybody. So I have a parameter that makes a decision about how often the families change house. And then if I change this parameter, if people go to the market and change houses more frequently, then the whole of the economy benefits. We also have, and it's a little bit paradoxical with number one, that small increases in taxes on a straight transaction and taxes on real estate, the property tax, would also lead to better economic output and less inequality. And also, firms should intensify labor market presence. But this is just first result, right? It's just a test. I haven't even published it yet because it's just a simple thing. Most parameters seem to be calibrated well, and my sample of configuration parameters in the end is not that large. I have only 232 pairs of configuration outputs. I would have to need to run more runs and have a larger sample to make a model more precise. The future, when Bill invited me here, and then that's it with the presentation, I was considering, well, what else can I do? It would be nice if I had the handle on machine learning techniques, such as I've seen on the internet, many-to-many neural network analysis and map the parameters straight to the outputs. I also considered making a multivariate analysis and globbing these outputs into a single compressed indicator and then run it and see. Just some ideas. Like I said, I'm really glad you could invite me here. This is just empirical work. I am at IPEA, and I would love to collaborate, and I'm open to questions. Thank you very much.
Questions? So Bernardo, I know we've talked a little bit about this before, but it's been a while since I've seen you, and especially given some of the turmoil in Brazil right now. I'm kind of curious how much of the work that you're doing in this space has the potential to actually influence policy in the long run. Okay.
We are in a favored position at IPEA, like I said, because we are in Brasilia. We have the mall of ministries, like where all the ministries are, and IPEA is just sitting there. And then all of my colleagues at IPEA, they work at the government, and then they come back. So we do have the ears of the policymakers, and we are very close to the decisions. We participate in the meetings. However, this specific topic is kind of unknown in Brazil. I was just talking to Matt, and they always want what also Paul Day said, they want those 2 pages and 1 picture, say, what do I do? They don't want me to explain that you have 67 parameters and then you can map to 13 outputs, and they want to say, okay, what do we do? And then what happens is that we get some attention from the media. So usually when we publish a paper or a book or do a conference, they run some news, and then that attracts some attention. So far I haven't influenced it yet, but I'm in a good position to do so in the future, I hope. Yep.
Well, I thought the whole talk was fantastic. It's great. The empirical work is amazing. The CA Metro fitting is really good. And I especially like the idea of, once you've validated it, then of course the targets don't have to be data. They could be desired macroscopic outcomes or other things, and even multiple objectives if you like. So I just think it's a very rich line of work, and I'm thrilled you could be here, and I look forward to collaborating with you on this. I think there are 1 million applications, so
Please.
Great.
Yes. Thank you very much. All right.
Well, maybe in the interest of time, we'll move on to Rob, who will be our last talk this morning. Thank you.